So the last presentation of today, as you have mentioned already, it is assessing the possibility for a circular economy for phosphorus in Lithuania. This research was done within the so-called project INFOS, what stands for Sustainable Management of Phosphorus in the Baltic Sea region, financed by EIT Raw Materials program. So at first, why phosphorus? Phosphate rock was included into the list of critical raw materials in 2014. Then with the third review of this list, in addition to phosphate rock, there was included phosphorus as well. What does it mean, critical raw materials? How is it decided that some materials are critical for EU countries? The basis for decision is economic importance plus supply risk of certain raw material. And here within this red square, you can see those raw materials that have been assessed to be critical for EU countries. And phosphorus and phosphate rock is among them. So do you see my screen well? Because I see some extra text, but it's only me who see that.
No, I can see it well.
Okay, then I will not just pay attention. So phosphorus, which is actually it is also made from phosphate rock. It is mainly needed for chemical industry applications, also a little bit electronics and metal products. Phosphate rock, it also has some other uses, such as in food additives or in production of detergents and fireworks. Nevertheless, the very main field of usage of need for phosphate rock is the production of mineral fertilizers. Phosphorus is among the main building blocks of our life, together with oxygen, carbon, hydrogen, nitrogen, potassium. So if there is no phosphorus, there are no plants, there are no animals, there is no agricultural production. And if there is no agricultural production, no food, and yeah, of course, that is not the situation that we would like to be in such a situation. So phosphorus is really very, very important raw material for us. At the same time, we all know that phosphorus also has its so-called dark side. In case there is a surplus discharge of phosphorus to water bodies, then we might result with eutrophication, which we do not want. So it is really important to balance what is happening with phosphorus. One might say that, well, actually phosphorus is really abundant. It is everywhere around. So what is the problem? The problem is that most of phosphorus is scattered around us, and it is not in a form which we could use for the production of mineral fertilizers. And those reserves that we are able to use, they are limited, and they are concentrated mostly in Morocco, also China. Nowadays, it is mostly China which is exploiting its reserves and mining and producing phosphorus. If we look at European countries, there is only one country which has substantial, well, so to say substantial, a little bit more substantial compared to other countries' reserves, and that is Finland, and therefore the only EU country having some mining of phosphate rock, it is Finland. If we look at phosphorus, so virtually there are just 4 countries in the world that have few factories with the production of white phosphorus. According to estimates, phosphate rock reserves, they are something for like 300 years. So again, one might say that, wow, it's quite long time slot. Nevertheless, we hope that humankind will last for 300 years and even longer, and even then people will want to eat. Food production will still be needed, and therefore it is important to think already nowadays what we will do when phosphate rock reserves are depleted. And also strategically, Europe should be independent in the supply chain of phosphorus. And although phosphate rock as such, it is not recyclable, nevertheless, phosphorus in different form, it can be recovered from different waste streams, such as wastewater, sewage sludge ash, also meat and bone meal, pig slurry, biomass. So in principle, there are possibilities to recover phosphorus. And therefore, there are already some countries that started taking steps in the direction of obligatory phosphorus recovery. Switzerland in 2016 was the first country in the world to make phosphorus recovery and recycling from sewage sludge and slaughterhouse waste obligatory. Germany was another country where a law in 2018 was adopted saying that phosphorus will be obligatory to be recovered from sewage sludge, either as such or from sewage sludge ash after mono-incineration of sludge. Of course, they gave some period to implement. Depending on a size of wastewater treatment plant, it's about 12 years period when this requirement needs to be implemented. What is the situation in other countries, among them in Lithuania and other countries of the Baltic Sea region? So in the mentioned INFOS project, we had a task to develop a strategy for sustainable phosphorus management in the Baltic Sea region countries, having in mind that phosphorus should become a part of circular economy, that it is very important to close phosphorus cycles. And at our institute, me and my colleagues, we took a task, one of subtasks, to perform phosphorus material flow analysis. And we started with development of conceptual model, then proceeded with estimation of phosphorus flows, and finally we go for flow analysis to see what are those flows, what kind and what amount of inputs of phosphorus do we have to our country? Where do we use phosphorus? Is this use efficient? Where do we have stocks, and what are the flows out of the country? So just to see all the picture, what is happening and what are the possibilities to have closed phosphorus cycles in our country. Our research is still in the process. Currently, we have preliminary balance and preliminary phosphorus flows for the country. We have 3 subsystems. That is production of mineral fertilizers, agriculture and food, and waste subsystem. Although Lithuania does not have its own phosphate rock reserves, nevertheless, we have one big company, and that company is producing nearly 2% of mineral phosphorus fertilizers in the world. and it is among the top 5 producers of diammonium phosphate in the world. So it's really important company, even on international levels, of course, also for Lithuania's economy and for employment in our country. And as we do not have our own phosphate rock reserves, we have to import resources. More than 1 million tons of apatites are imported mostly from Russia, also South Africa, Morocco, other countries. And what is interesting that actually about 98% of the production of all those produced mineral phosphorus fertilizers, they are exported out of the country. And most of fertilizers that we use inside our country, they are brought, they are imported from other countries. And of course, the main use is in agriculture, Lithuania, as it's in most other countries as well. So to summarize, main flows to Lithuania are calcium phosphates, that is for production of mineral phosphorus fertilizer, also fertilizers themselves, and also about 9% of phosphorus comes to Lithuania with import of various food and feed products. If we look at exports and how phosphorus is escaping our country, so it is mostly exported with fertilizers and again also with feed and food. In Lithuania, we have significant production, agriculture related to crop production and livestock farming. And again, a large share of that production is exported. And therefore, phosphorus is transported out of the country together with these products. If we look at cereals, at crops and different cereals like wheat, for example, they are really rich in phosphorus compared to other agricultural products. And they accumulate really big amounts of phosphorus, and all that phosphorus leaves the country without possibility to recycle it and return to agriculture. Sorry, it's a little bit mess with my with my slides. So to summarize, import and export of food and feed in Lithuania, we have a negative ratio. And if we would look to the average situation for EU countries, EU average is a positive number. In Lithuania, it is negative, and for this reason, the possibility of recovery of phosphorus from secondary sources is decreasing in Lithuania. Another point, what we have in Lithuania compared to EU average, we consume more mineral fertilizers rather than organic fertilizers. So that is another point to be improved in the country. If we look at losses, where do we lose phosphorus? Not just really export, but really lose it. So one of the points, it is losses from agricultural areas, and also discharges from wastewater treatment systems. It doesn't matter how clean do we treat water, still some amount of phosphorus remains, and then that phosphorus is discharged to waters. Sorry. And excuse me. Sorry, this is a little bit when you talk from home conditions. So um, well, I lost a little bit my mind. Yeah, so we lose it with discharges from wastewater treatment plants, and also a substantial part of phosphorus is retained with wastewater sludge when it is stored and landfilled in polygons. How do we mostly recover? Mostly we recover phosphorus with manure and slurry, and also compost from biodegradable waste, and again still with sewage. So actually, although as I mentioned, we kind of lose and we still store a lot of phosphorus with sludge. But if we look at the amount of sewage sludge which is being used in agriculture, or which goes for composting together with different green waste in Lithuania, we do have that rather substantial part of this compared to other countries. Like there are some countries that do not want sewage sludge to be used nearly at all because of contamination issues, because of various micropollutants. In Lithuania, we still have this substantial usage. Now, yeah, so here is my figure that compared to average EU, we use substantially more phosphorus from sewage sludge. And to summarize my insights from the flow analysis, although as I mentioned, it's still preliminary flow analysis, but some insights can be already drawn from it. So Lithuania is economically and socially vulnerable with regard to availability of primary phosphorus resources. And that is because of this our important mineral fertilizer production plant. Lithuania is dependent on phosphorus fertilizer import for its own agriculture because of our agriculture and food import-export profiles. Because we export more phosphorus with food compared to our import of phosphorus with food. We should pay attention to our agricultural practice because there are still possibilities to minimize phosphorus losses from agricultural areas. We need to pay attention to our sewage sludge management, although currently we have substantial recovery through sludge use in agriculture and in composting. Nevertheless, when we think about future sludge management practices, it is important not to forget micropollutants issue, and also not to forget that we are going for certain incineration of sewage sludge. Currently, we have already a certain amounts of dried sewage sludge which is intended to be incinerated. So the question is whether we will just incinerate it or whether we will go for recovery of phosphorus from incineration, and whether we will have mono incineration or co-incineration of that sludge. And it is important to think about cooperation, both within our country and also on regional level, together probably with other Baltic countries, because actually total amounts of phosphorus or of sludge, for example, they are not really very big. And to have cost-efficient solutions, it is important to have certain critical amount of sludge, for example, which can be mono-incinerated, and so on. So it is really important to think about cooperation with between different stakeholders. And thank you for your attention.